Thank you for introduction. So I'm Sato. I'm going to talk about the programming model to integrate the quantum computer with the classic HPC system, especially supercomputer like a Fugaku. So this is the overall the project in a R-CCS related to the quantum computer. So this project is done with a collaboration with the RIKEN Center for the Quantum Computer. So first sub-project is the development of the large-scale quantum computer simulators using the Fugaku. So we have two kinds of the simulators. One is the bracket, which is developed by the Dr. Ito. This simulator is used for the large scale to the medium scale simulation. The qubit number of qubits is about 50. And another the simulator is CRUX, which is developed by the R-CCS Fujisan team. This is the little bit small scale, medium scale to the small scale. So we have two kinds of the simulators, and this simulator is running on the Fugaku. So, and for development these softwares for the Fugaku, the development are supported by the program, the enhancement of the Fugaku usability for the Fugaku CPU resources. So another part is the programming model. This is my part, the design of the hybrid programming environment for the integrating the quantum computer or quantum simulators, computer simulators with the classic HPC. So we are focusing on a workflow or task parallel programming for offloading some function to the quantum computer. And we are also interested in the design and implementation of the common framework such as QBO. And by using these kind of the software, so we are going to design the QC algorithms and development the quantum application for the quantum computer and the HPC hybrid computing. Especially target at this moment is that material simulation for the optimization on the ground state of the molecule by the VQE method. Using the large scale quantum simulation using the more than 40 qubit of the quantum computer simulator on the Fugaku. And last one is that the research on the architectures to accelerate the quantum computer simulation. So to accelerate quantum computer research, the technologies for high-speed the quantum computer simulation is important, and this part is led by the Dr. Kondo-san team, and using the GPU. So their group is researching how to accelerate in quantum simulation, and also examine the more advanced architecture to accelerate the quantum research. And my team is working for this part. So mission one is to make use of the quantum computer simulator on the Fugaku. As I said, we have the two kinds of simulators, bracket and CRUX. And our team is doing the performance tuning for the Fugaku and also design and implementation of the common framework, such as the QBO or Squid in IBM. Another mission is the integration the quantum computer with the classic supercomputer. We are focusing on the workflow, task parallel programming for integration. So the coarse grain task, the parallelisms using the quantum computer and the classic computer for cooperative the computation of the QC and QCC. And in this programming model, the algorithms by the executed by the quantum computer is recognized as a task in this programming model. And also, before, of course, quantum computer is not available now. So instead of the real the quantum computer, we are working for the large-scale quantum simulation for this part. So recently, some people is talking about the theta scale since the exascale computing almost coming. But theta scale, what is a theta scale computing? So I think theta scale we are talking about is that the next of the exascale is defined as the some system architectures beyond the exascale. So in that sense, possible theta scale system, this is not a theta flop system, will be the integration of the many kind of acceleration technologies such as CPU and FPGA and reconfigurable devices or accelerators architecture specific devices. And some nodes has these kind of architectures, these kind of the accelerators like this, and also the cluster of the various kind of the clusters, specialized machine as a quantum computer, is connected by the network. So like this. So I think in the future, the theta scale system will be this kind of the configuration. So, okay. So important programming will be supporting the various kind of the task offloading. So for example, offloading within a node is offloading to the GPU and FPGA with a common API such as OpenShare, like this. So another form is that the offloading outside of node, like this. So and quantum. So the general purpose supercomputer system is connected by the cluster of the various kind of the system. So I think the task offloading to the quantum computer is one of these. So what is the task programming? So task programming is introduced by the OpenMP. So task directive in our OpenMP is create a task with a dependency specified depend clause like this. So this is an example. By executing this the program, so the OpenMP, the program is making this task graph, and this task is executed by the runtime. And for example, this is the Koreski factorization example. Compared to the classic the OpenMP program, the task programming OpenMP task programming is generate a task like this and executed by the task runtime. Currently, we are working for the global task programming. So that means that the task is distributed over different nodes. So, and the name of the model and language is Excalibur MP. So, and this programming model is supporting the various kind of task offloading. So, as I said, offloading within a node, and of course, offloading outside of node, offloading to the cluster of the accelerators like the quantum computer. As a prototype, we are working for FPGA clusters. So actually, some small FPGA cluster is connected to the Fugaku currently. So, and we are using this the system as a prototype of the offloading model. So in this the configuration, so some kernel is offloaded to this FPGA clusters. So, and the result is taken back to the supercomputer. So, and to offload, we are developing some kind of the remote procedure called the runtime, so called the OmniRPC. This OmniRPC is originally developed for the grid the environment. So we are using this RPC mechanisms to offload the many parts to the another cluster. So task parallel programming plus remote procedure call is the supporting the offloading to some function to the specialized clusters like FPGA on the quantum computer. So a task in a thread is offload the predefined kernel to the remote node like this. This is the remote procedure call. And OmniRPC is extended to manage the request, several requests to the another clusters, avoiding the blocking the thread in a supercomputer's task. So, and idea is simple. They're using OmniRPC to integrate the quantum computer system or quantum computer simulators with a classic system like this. So, currently the FPGA cluster is there, but we can replace this part now the quantum computer or quantum simulator. So this is the overall structures. The task graph is generated by the task programming, is executed on a supercomputer, and some part is offloaded by the RPCs. And this RPC is invoked a kind of function in a quantum computer or quantum computer simulator. So, and in this part, the set of the quantum computing operation. So, for example, quantum algorithms using the quantum computer is executed in this part here. So, and the supercomputer is not request the remote function to directly supercomputer directly. So we assume that some CPU system or the conventional CPU system sit in front of the quantum computer to control the quantum computer and the hardware. And this remote function, which is executed in this front end, is very control the quantum computers and set up and execute a specific routine or circuit on a quantum computer. So this is the typical the example of the remote procedure call description. So the name is the quantum computer task. So so typical the procedure will be like this. So pre-process, taking the argument here, and set up and start the quantum computer program. And then the execution is over, taking back the result and send back to the classic supercomputer system. So, and this part is this program will be written in QBO or QSCAT. So this is the framework proposed by the Virgin Q. And this the language is a kind of description of the quantum program or quantum circuit. And also for the simulators, Quark's script in Python is executed by the quantum simulators here. So, and the current QC and classic hybrid program can be the single remote function like this, and each step pre-process and offloading and the post-processing can be written like this. Okay, so to conclude my talk, so we are proposing the global task programming with RPC, which offload a kind of the quantum algorithms to the quantum computers to integrate the quantum computer with the classic the HPC, especially in a supercomputer. So in this context, the overall the programming model or the next of the exascale or the data scale computing should support the various kind of the task offloading. The quantum computer offloading is one of these. And this model is already implemented and validated for the FPG clusters ESPA, which is connected via the Fukaku. And this is the future plan, things to do. We are currently working on design the implementation of common framework, such as the QBO and the Quarks and API for the quantum computer simulators. And our final the target at this moment is that implementation and the evaluation of the quantum application. And as I said, so our current target is the material simulation for optimization of ground state molecule by the VQE using the large scale quantum computers on a Fukaku, quantum computer simulators on a Fukaku. So thank you for your attention.